whalawata maiti. O le whaopoponga le nei. O le tatou le sona. Mo le matematika. Mo le tausanga iwa. Ma le sefuru. Okay, let's look at our topic. So our topic talks about algebra with a learning outcome of simplifying algebraic expression using the laws of indices. So let's look at the board and identify what are those laws or rules are. So we have our law of indices on the board. So say we have p to the power of p. So p here, it's what we call our base. So remember, the number here, it's called the base. To the power of p, this p we call a power. Okay, so please remember, law of indices, it's also known as laws of powers, laws of index, or what we call the law of exponents. So whenever we say we are talking about the law of indices, so basically we are talking the law of powers or law of exponents. So they all mean the same thing. So now we know what we call the base, and the power there, it's what we call the power or index, or what we call exponent. Okay, so our first law here, our first rule, a to the power of m multiplied by a to the power of n, the answer will be a to the power of m plus n. So basically what the rule says, when you multiply two terms with the same base, so base a, all you have to do is to add the powers. So m here plus power n here. So therefore the answer for a to the power of m times a to the power of n is equal to a to the power of m plus n. Let's have an example for number 1. So say we have a to the power of 4. So m here is equal to 4. And then we multiply by a to the power of, say, 5. So a times a to the power of 4 times a to the power of 5. Now we are multiplying two terms with the same base. So all we have to do, add the powers. So, and here is how we do it. So a to the power of 4 plus 5. Therefore, our final answer, a to the power of, yes, a to the power of 9. So the answer for a to the power of 4 times a to the power of 5 is equal to a to the power of 9. And that is our rule number 1. Rule number 2, it's totally the opposite of our rule number 1 or law number 1. A to the power of m divided by a to the power of n. We can also rewrite this in the form of a to the power of m over a to the power of n. So these two presentations are the same. So when we divide two terms with the same base, we minus the power. So that's why we have a to the power of m minus n. So let's have an example to illustrate our rule number 2. So say we have x to the power of 10. And then we want to divide it by x. Okay, so now we have x to the power of 10 divided by x. This can be rewritten in this form as x to the power of 10 divided by x. Remember, x here has an invisible power of 1. So x here, we can say this is x to the power of 1. So x to the power of 1 is just the same as x. So because we are dividing two terms with the same base, so all we have to do is minus the power. So this is x to the power of 10 minus 1. The answer will be 9. So the answer for x to the power of 10 divided by x to the power of 1 is equal to x to the power of 9. And that is how we do our rule number 2. So our first one talks about multiplying terms. The second talks about division of the two terms. Now our third one, we have a to the power of m and o to the power of n. Okay, so again, this is a to the power of m, o to the power of n. So what's that mean? So we have a term a to the power of n here, and that is o raised to another power n. So when we have cases like that, so the rule says when we have something like this, all we have to do, we multiply these two powers. So m multiplied by n. So that's why we have a to the power of m, which is this one, and then multiply by n, which is the power outside. So under the simplifying algebraic methods, so m times n is just the same as mn. So that's why we have our final answer as a to the power of mn. Again, so we're going to do an example to know more about this rule. So say we have bracket of, say, y to the power of 3, and this is o to the power of 5. So again, when we have y to the power of 3 raised to another power of 5, all we have to do is to multiply the power. So this is y to the power of 3 multiplied by 5, and our answer will be y to the power of 3 times 5 is 15. Okay, so followed by the same format, say we have two different terms inside a bracket and all raised to a power outside. So we have a to the power of m, b to the power of n, all of this in bracket, we are raised to a power of x outside. So what we have to do here, we need to multiply the power outside to all the powers inside our expression there. So x will multiply to letter m here, and x will multiply to letter n as well. So now we have a to the power of x times m, that's why we have xm here. And then b, x times n is equal to xn. So the answer for this one is a to the power of xm, b to the power of xn. So please note, we have two different base and two different terms. So that's why we're not allowed to add those powers, because base A, it's different from base B. So example for this one, so say we have x to the power of 3, y to the power of 6, and this is all to the power of 2. So now 3 here will be raised to that 2, and so is 6. So our answer will be x to the power of 3 multiplied by 2 is equal to 6, and y to the power of 6 times 2, the answer will be, yes, 12. So the answer for that one is x to the power of 6, y to the power of 12. The last two cases, it's basically not really what we call rules. So the first three are basically laws of indices. The last two, it's what we call special cases in maths. So these two special cases is what we call zero exponent or zero power and the negative power. So the first one, we say a to the power of 0 is equal to 1. So that rule says whatever is to the power of 0, so anything to the power of 0, the answer will be 1. So when we have x to the power of 0, the answer will be 1. When we have, say we have a house to the power of 0, the answer will be 1. So simply means anything to the power of 0, the answer is 1. The last one, we have a to the power of negative 1. That is equivalent or equal to 1 over a to the power of 1. So as you can see here, so now this a to the power of negative 1 is the same as a to the power of negative 1 over 1. And then we are going to flip them. So when we flip them or we take the reciprocal, it will becomes, the power will becomes the opposite. So now a as a numerator, the power is negative 1. But now we are putting down as a denominator, so instead of the power of negative 1, now it's positive 1. And please remember that anything to the power of 1 is just the same as the base itself. So that's why 1 over a to the power of 1 is just the same as 1 over a. So examples of this one, say we have x to the power of negative 5. The answer for this one, this is 1 over x to the power of 5. Also, if we have x to the power of negative 4 over y to the power of negative 3, that is equal to, we can flip this one to become positive powers. So this is y to the power of positive 3 over x to the power of positive 4. Now we have our 5 rules and 5 laws for our indices of how to compute and to do operation and simplifying our algebraic expressions using the laws of indices. Now, so let's go ahead and do some more examples so we can have a look in detail of how the laws of indices it's being applied into different situations. Okay, let's have some examples so we can have more detail and more understanding of how to simplify our algebraic expressions using the laws of indices. So the instruction says simplify this. So simplify simply means, so make your statements as simple as possible. So the other way to make it easy for us to look. So number 1, say we have x to the power of 6 times x to the power of 3. So what we have to do here, now we're going to apply our rule number 1. When we multiply two numbers or two terms with the same base, all we have to do is to add the powers. So now the answer for this one is x to the power of 6 plus 3. So the answer x to the power of 9. Yes, 6 plus 3 is equal to 9. That's our first one. For the second one, so we have variable y here multiplied by y to the power of 5. So now we are doing another case with multiplying the same base. Now we're going to add the powers. But for our number 2, we have just the term y here. So again, we say that y is just the same as y to the power of 1. So all we have to do is to add the powers. Now y to the power of 1 here plus power of 5 here. So our final answer or our simplified answer will be y to the power of to the power of 6. And that is the answer for our number 2. The third one, as you can see, now we have 4x to the power of 2 times 3y to the power of 5 multiplied by 5x to the power of 7 and then multiply again by negative 2y to the power of 6. So in this case, we have two different variables or two different bases. So our first base is x, another base here is y. So when we simplify, we are still doing the same rule. When we have the same base, when we multiply the same base, we add the powers. When we divide, we minus the power. So let's simplify them by putting together our base x so as our base y, so we can see a easy thing to look. So for this one, we're going to bring our 4x squared here and then look across if we can find another base x here. So now we have there 5x to the power of 7. So we're good with our variable x. What about our variable y? Now we multiply 3y to the power of 5. And then the last one, we multiply with the last one here, negative 2y to the power of 6. So now we have the collection of y here, of x here, and the collection of our y here. So all of that is multiplied. So the last thing to do is to simplify them using our laws of indices. So 4x squared multiplied by 5x to the power of 7. So 4 here we will multiply to 5 because they are coefficients. So we multiply the coefficients straight away. So 4 times 5 is equal to 20. X to the power of 2 multiplied by x to the power of 7. That will be x to the power of 2 plus 7 is equal to 9. And that is done for our variable x. Now our variable y here, we have 3y5 multiplied by negative 2y to the power of 6. So 3 times negative 2, the answer will be negative 6. And y to the power of 5 multiplied by y to the power of 6, that will be equal to y to the power of 5 plus 6. The answer will be 11. Okay, we're not done yet. So now we have our collection of x, so with our y. So because this is a multiply, we are still continuing with our simplified method. So now 20 multiplied by negative 6, the answer will be negative 120. And x to the power of 9 multiplied by y to the power of 11 will remain the same, x to the power of 9, y to the power of 11. And that is our final answer. So now you can see we have a long stream of our variables here, but our simplified answer ends up to negative 120, x to the power of 9, y to the power of 11. The next one, we have 35x to the power of 4 divided by 7 to the power of x. So when we look closely to this one, this is 35 divided by 7. So we can either do this by cancellation or we can do it by dividing straight away. So 35 divided by 7, that is equal to, yes, 5, because 5 times 7 is equal to 35. And then we have x to the power of 4 divided by x. So remember this x is to the power of 1. So because we are dividing the variable x, our rule number 2 says when we divide the terms with the same base, we minus the power. So now we have x to the power of 4 here, and then take away 1. So the answer for our number 4 in a simplified form will be 5. x to the power of, yes, x to the power of 3. So 5x to the power of 3. And that is the answer for our number 4. So let's have some more examples. So our number 5 talks about x to the power of 2a and then divided by x. So it doesn't matter what our powers are. So now our power here is 2a, something a little bit different. And the power of this x is equal to 1. But what can we observe from doing our laws of indices or laws of powers? We can say when we divide two terms, which is this term and this term, with the same base, so this is base x, this is base x, all we have to do is to minus the power. And that is what we're going to do. So now in this case, we have base x to the power of 2a and then minus the power of 1. So it looks like we have x to the power of 2a minus 1. Because we can't simplify 2a minus 1 further, so we can say our answer for number 5 will be x to the power of 2a minus 1, according to our law of indices. The next one, we have 4a cubed b squared c. So all of that will be raised to a power of 3. Okay? So let's have a breakdown of this situation here. So we can say that all the terms inside the bracket will be raised to a power outside the bracket. So that means all this 4 here is to the power of 1, a to the power of 3, b to the power of 2, and c here means c to the power of 1. So when we break down this stuff, this is 4 to the power of 1 times 3. The answer is 3. A to the power of 3 times 3 here is equal to 9. So remember, we are multiplying the powers, not adding the powers. So b to the power of 2 times 3 is equal to 6. And c to the power of 1 times 3, the answer will be 3. So now we have some explicit situation there, so we can go through and identify one by one. So now the final evaluation, if we have 4 to the power of 3, that's 4 multiplied by 4, and then multiplied by another 4. So 4 multiplying 3 times. So 4 times 4 is equal to 16. And then 16 multiplied by another 4, the answer will be 64. So 4 to the power of 3 is equal to 64. Now our a to the power of 9 remains the same, so as b to the power of 6 and c to the power of 3. So that is our final answer for our number 6. So the answer for 4a cubed b squared c to the power of 1 or to the power of 3 is equal to 64a to the power of 9, 4 to the power of 6, and c to the power of 3. Very good. We're almost done with our examples. For number 7, we have something inside the brackets which is 3x all to the power of 0. So this is another classic example of our zero exponent. So because we have 3 to the power of 1 and x to the power of 1 here, with the understanding that anything to the power of 0 is equal to 1. So this is 3 to the power of 1 times 0 is equal to 0. We are multiplying 0 inside, and this is x to the power of 0. So 3 to the power of 0 is equal to 1. X to the power of 0 is equal to 1. So 3 to the power of 0, that's 1. We can multiply by x to the power of 0, which is another 1. And 1 times 1, the final answer will be 1. So going back to our law for zero exponents, that anything to the power of 0, the result will be 1. The last one here, we have 2xy all to the power of 2 multiplied by 3, and then the brackets of 3xy all to the power of 2. All of that will be divided by x squared, y squared. So remember, square is just means to the power of 2. So it looks hard at this moment, but if we are going to identify one by one, we can easily see how our laws of indices is being applied to each one of them. So let's go and have a breakdown with those ones. So again, we know that this one, applying the law, we multiply this power of 2 inside. So we have 2 to the power of 2. Remember, this is to the power of 1, 1, 1. So x to the power of 2 and y to the power of 2. Now the next one, we are multiplying by 3. Remember, this 3 is independent. And xy here, it's raised to a power of 2. So again, we have that invisible power of 1. So now we have x to the power of 2, y to the power of 2. Great. This is all over x squared, y squared. So the final state, it's basically trying to evaluate one by one. So this is 2 to the power of 2. And we understand that 2 to the power of 2 is equal to 4. Now that 4 there, multiply to this 3. So 4 times 3 is equal to 12. X to the power of 2 multiplied by x to the power of 2, that will be x to the power of, great, x to the power of 4. Because we are adding the powers if we multiply two terms with the same base. So as y to the power of 2, y to the power of 2, that would be y to the power of 4. And then this one will be divided by, so x squared, y squared. So x squared, y squared. So now this x will correspond to this one and y as well. So under the rule number 2, if we are dividing numbers with the same base, we minus the power. So this 12 will remain the same. This x will be x to the power of 4 minus 2, which is 2. And then y to the power of 4, take away this 2, the answer is 2. And looks like that will be our final answer for our number 8. Our activity on the screen will provide more solid information and solid equation, so we can have some more understanding and more informative on how to simplify our algebraic expressions using our laws of indices. So number 1, we say 3a to the power of 5 times negative b multiplied by 5a multiplied by 6b to the power of 4. Now we have two different variables, so we have variable a here and variable b there. So as our discussion with our examples, so what we are going to do, we're going to put together our variable a, and so as we do to our variable b. So 3a to the power of 5, so we're going to bring that down. So 3a to the power of 5, and then we multiply by 5a. Then we multiply by b here, that's negative b, and then multiply by 6b to the power of 4. So now we have 3a to the power of 5 times 5a multiplied by negative b times 6b to the power of 4. So all of those numbers was derived from what we had on the top. So what we are going to do next is to simplify them by using our laws of indices. So 3a to the power of 5 times 5a, so we multiply 3 to 5 that will be equal to 15. And a to the power of 5 times a, which is a to the power of 1, the answer will be a to the power of 6. And then we multiply on this side, we have negative b, which is negative 1, multiplied by 6. Then we have our negative 6. And then b multiplied by b to the power of 4. So this is b to the power of 1, multiplied by b to the power of 4 is equal to b to the power of 5. And then the last thing we need to do, 15 multiplied by negative 6. So 6 multiplied by 5, that will be 30. So 0 carry 3. And 6 times 1 is equal to 6 plus that 3, that will be 9. So positive times a negative, the answer will be negative. So 15 times negative 6, the answer will be negative 90. And a to the power of 6 times b to the power of 5 will remain the same. So a to the power of 6 and b to the power of 5. So the final answer will be negative 90, a to the power of 6, b to the power of 5. And that is the answer for our number 1. For number 2, we have 65c to the power of 2 divided by 5c to the power of 5. Now we have our coefficient here, so 65 and 5, and our base c here. So c is our base. So because we are dividing them, so 65 divided by 5, the answer will be 13. And c to the power of 2 divided by c to the power of 5, that will be c to the power of 2 minus 5. So our final answer, this is 13 c to the power of 2 minus 5 is equal to negative 3. So now we can see something that's negative power here. So in a simplified form for a negative power is to change to become a positive power. So in this case, now we're going to bring c to the power of negative 3 to the denominator to make the power positive. So this is 13 here divided by c to the power of 3. So remember, c here as a numerator, the power is negative. Now we're bringing down to the denominator, so the power will be positive 3. So the answer will be 13 divided by c to the power of 3, or 13 over c to the power of 3. The third one, we have the situation on the board. So 2x squared y, all of that will be raised to the power of 3, multiplied by 4xy, all over or all divided by 2xy all to the power of 3. So as we all know from our rules of or laws of how to operate, we're gonna take care of the multiplication on the top first, and then we take care of the division last. But before we do that, we need to understand our laws of indices in order to take care of that multiplication. So the top part, let's have them in detail. So this 2 will be 2 to the power of 3, x to the power of 2 times 3, which is 6, and then y to the power of 1. Remember, there is a 1 here. 1 times 3 is equal to 3. All of that will be multiplied by 4xy, all divided by, so 2 here, it's raised to a power of 3. So 2 to the power of 3, x to the power of 3, and y to the power of 3 as well. So now 2 to the power of 3, that is equal to 8. 8 multiplied by 4, that will be 32. So 4 times 8 is equal to 32. x to the power of 6 times x here, that will be x to the power of 7, because 6 plus 1 is equal to 7. And then y to the power of 3 plus 1 here, that will be y to the power of 4. All of that will be divided by 2 to the power of 3, which is 8, x to the power of 3, and y to the power of 3. So the last step is to do our division last. So 32 divided by 8, the answer will be 4. X to the power of 7 divided by x to the power of 3, that will be x to the power of 7 minus 3, the answer will be x to the power of 4. And then y to the power of 4 minus y to the power of 3, that will be equal to y to the power of 1, or we can say that will be just y. So the answer for our number here, it's 4x to the power of 4 y. Again, the answer for number 3, it's 4x to the power of 4 y. The next one will be a little bit more complicated, but when we use our certain laws that we discussed earlier, so it will be easy to us to apply and have a simplified answer. So the top one here, we have 5 multiplied by 8. The answer will be 40. X to the power of 2 times x to the power of 3, that will be x to the power of 5. And then we have our last y there to put it down. The bottom part, we have 10 times 4, that will be 40 as well. X to the power of 4 times x here, that will be x to the power of 5 as well. And then y here will be putting down. So when you observe our step there, you can see that the top one, we have 40x to the power of 5 y. All of that will be divided by another 40x to the power of 5 y. So we can easily simplify that by doing the cancellation. But because we are talking about our laws of indices, so the laws of indices will produce the same result as well. So going through our laws of indices, so 40 divided by 40, the answer will be, yes, 1. Let's put a multiply between them to identify them. So now I'm going to multiply by x to the power of 5 divided by x to the power of 5. That will be x to the power of 5 minus 5 because of the division. So that will be x to the power of 0. And then we're going to multiply to y to the power of 1 here, minus that power of 1 here. So it will be y to the power of 0 as well. So therefore, it looks like we have 1 here multiplied by x to the power of 0. Everything to the power of 0 is equal to 1. So x to the power of 0 and y to the power of 0 will be equal to 1. So that's a 1 times 1 multiplied to another 1. The result will be 1. So again, if you can look at this one, you can see you can do your cancellation here as well. So if you want to cancel this one, so 40 here will be cancelled out with this 40. So x to the power of 5 will be cancelled out with x to the power of 5, and so is 1. So the final result will be 1 as well. So going through the laws of indices and simplified by cancellation, we will have the same result. Okay? We have brackets with 5a to the power of 2b divided by 10ab squared, all of that raised to a power of negative 3. Okay? So again, we have 5a squared b, all of that will be divided by 10ab squared, And the whole bracket there will be raised to a power of -3. So now we have some case with a negative exponent or the negative power. So from understanding to our laws of indices, we can say that, so in this case, so instead of raising to a power inside at this time, let's flip what's inside the bracket and take the opposite of the power. So this is how we do it. So our denominator here will become our numerator, so that will be 10ab squared divided by, that's numerator, will come as a denominator, so 5a squared b, all of that will be raised to a power of, instead of -3, because we are flipping them, the power becomes +3. So now it's time for us to have a look and do our simplification. So in this case, I am going to simplify what's in the bracket first and then raise to a power last. So inside the bracket, we can, so 10 divided by 5 here, the answer will be 2. So that will be 2. A here, divided by a to the power of 2, that will be 1a at the bottom. And then b squared divided by b, it will be 1b at the top. So the simplified form of this one, so let's have a look here of how we are coming from this form to this simplified form. So 10 divided by 5 is equal to 2. A divided by a to the power of 2, that will be a to the power of 1 minus 2. So 1 there, minus 2 here. And then b to the power of 2 minus 1 there. So that will be 2 minus 1. So that will be 2 minus 1. So when we simplify that one, we have 2 here. A to the power of 1 minus 2, that will be a to the power of -1. B to the power of 2 minus 1, that will be b. So another way of writing this one, so we have 2b here, and we're going to bring a to the power of -1 to the bottom. So that's why we have 2b over a as reflected here. So all of that will be raised to a power of 3. So going through the same case, so we have 2 to the power of 3, b to the power of 3 over a to the power of 3. So this 3 will multiply to this power of 1, multiply to another power of 1 here, and also another power of 1 in our denominator. So last step of this working out, 2 to the power of 3 will be 8. Then we have b to the power of 3 over a to the power of 3. And that is the final answer for our last one in our activity. O le nata maiti, le taunu unga le tatou wasenga le nei aso, mo moli atu le nganga whaafitai, tu sai fo ima le lava papale, e maisi o le whaalongolongo mai, i le tatou le sona, o mo whai ona whaatau no ina le nei aso. Tu le tau mai le so onga le tatou le sona, tō whaasoi fua.